Today we're going to examine the volume of a cylinder. A cylinder is a prism which has a base shape that is a circle. You can see that with some of these objects. The blue cylinder, the pop can, and the oil drum all have identical faces on opposing sides that are circles. Cylinders are very commonly occurring prisms, and the problem of calculating volume is often seen by packaging designers who look at trying to find the best way to fit the most product into a space. Chain stores will hire planners to design shelf layouts that hold the maximum amount of product in the best position for customers to see and purchase. Any areas that have empty space, like above these shapes, and seen in black there, are not optimal uses of space, and we will try to eliminate those as best we can. And this often becomes a juggling act, because cans are made in many different sizes. People are hired to come in and verify that the space they paid for on the shelf is being used properly. Look at the top shelf of Pepsi cans here. Although this nice tall can looks good on the shelf, there's a lot of empty space at the top. The goal here is to eliminate empty space. We can see how a shorter, more well-designed can uses the vertical space a lot better. There's hardly any space to see in the shelf at all. The height of a cylinder must be considered when we're looking at getting the best use of our shelving space. Another consideration is the problem of how wide each can should be. Here we have 6 cans sitting on a shelf. There's a fair amount of yellow space between the cans though. The object of a designer is to eliminate the yellow space. So we'll ask the question, does a smaller diameter achieve this? We'll take a look at what happens when we look at a smaller diameter can. We fit many more of them on the shelf, but there are a lot more yellow spaces. Is there more yellow space in total? That's a question that we'll have to actually consider the area of a circle and the volume of a cylinder to solve. And today we will solve this problem. But first we need to know how to calculate the volume of a cylinder. Recall from earlier lessons that the volume of a prism is equal to the area of its base times its height. Since the base shape is a circle, we need to find the area of a circle. Recall from last year that the area of a circle is given by the formula pi r squared, where r is the radius of the circle. Remember that the radius of a circle is simply the distance from the center to the edge. It doesn't matter in which direction you measure it, it's always going to be constant. And the number pi. Well, the number pi is 3.1459, and it goes on forever. But just for calculation's sake, we use the number 3.14. Let's see these formulas in action and calculate the area of some circles and the volume of a cylinder. First example, let's find the area of the circle below. Well, the formula for the area of a circle is given to us. It's pi r squared. We have to choose the values that we're going to put into this formula. The r is going to come right from the diagram, the 5 centimeters. The value of pi is always known to be 3.14. So let's substitute these values into our formula. We're left with 3.14 times 5 centimeters squared. The next thing we have to do is bring the exponent 2 into the brackets by raising each of those elements to the exponent 2. We'll be left with, in the brackets, 5 squared and centimeters squared. Also note that the 3.14 just gets carried down. We've done nothing with it yet, so we leave it alone. In our next step, we're going to simplify inside the brackets. We can express 5 squared as a standard number. When we do that, we'll call it 25, because 5 times 5 is 25. And again, you'll notice 3.14 is carried down. As well, the centimeters squared is carried down because we've done nothing with it. The next step that we have to do is multiply 3.14 times the number 25. When we do this, we'll find that we come up with 78.5 centimeters squared. And that's the area of the circle that we were given in the diagram. The next example asks us to find the volume of a cylinder with a radius of 10 centimeters and a height of 10 centimeters. It's a cylinder, so its base shape is going to be a circle. If we draw a circle and a radius and add a label, it becomes a little bit easier for us to see which values we're going to put into the formula. The radius was 10 centimeters squared, so I'll indicate that on my diagram. And the height is 10 centimeters. The next thing I'm going to do is substitute the formula for the area of a circle into the area of a base spot of our volume formula. So we're left with the volume of a cylinder is equal to pi r squared times height. And that's because the area of a circle is pi r squared, and we're going to just call the height h. This is the most common formula that you will see for the volume of a cylinder. Pi r squared times height. The next thing we're going to do is substitute the values that we know into the formula. Recall from the question that there was a height of 10 centimeters. So we can put that in for h. And also a radius of 10 centimeters. We can put that in for r. And keep in mind that pi is always 3.14. So that's the last value that we'll substitute, leaving us with 3.14 times 10 centimeters squared times 10 centimeters. Then next, we need to bring the exponent 2 into each of the items in the bracketed expression. 10 squared is 100, and centimeters squared is centimeters squared. Just a reminder that any items that you don't do in a calculation in a step must be carried down to the next line. The next thing we can do is simplify by multiplying. The order of our multiplication doesn't matter because that's all we have left to do. We have 3 numbers and we have to multiply them together. We'll multiply the 3.14 by 100 centimeters squared first because that's the first one we see. That leaves us with 314 centimeters squared multiplied by 10 centimeters. Notice the bases. Centimeters squared and centimeters have the same base, so we should add their exponents because we're multiplying. When we add 2 and 1, we should come up with an answer that's in centimeters cubed. And then we just multiply the numbers. 314 times 10 is 3,140 centimeters cubed. So the volume of our cylinder in question is 3,140 centimeters cubed. That's it for the lesson for this portion of our volume investigations. Please log on to Digital Courseware, look up Unit 3 on powers, and go to the 3rd section regarding volume and volume of a cylinder.